Okay, students, we're going to talk about parabolas today. We're going to talk at we've already gone over the algebra 1 type of parabolas when you're given in standard form, vertex form, and factor form. Now we're going to talk about a different form that usually has been in pre-calculus and then has moved down to algebra 2, and the first time I've seen it in geometry. So it's still parabolas, except for we're going to have parabolas that open as you see right here, left and right, not just up and down like you did in algebra 1. And it's a different form. Okay, so let's first talk about what the true definition of a parabola is. As you see here, a locus of points, a set of all points that share a property. Okay, so that's going to be dealing with a parabola. It says, here's our definition right here. Excuse me. A parabola is a set of all points. That's that locus of points in a plane, flat shape, equidistant from both a focus and a directrix. So let me change the color. Here's a focus right here, and here is the directrix. Usually you have it dashed because it's truly not part of it. The parabola itself, make it red, is the only part of the actual answer. So the focus is not really part of the parabola itself, and neither is directrix, but it's all related to it. So things that aren't part of it, if it was a line, you'd usually dash it. Okay, that's why it should be dashed. All right, so the focus, first off, as it says right here, is a point. So notice it's a point, it's not a line. The directrix is a line. Okay, the focus is a point. So you know x comma y, not a line, not some equation. Versus the directrix is a line. So it's going to be y equals a number or x equals a number. Okay, obviously x equals a number is vertical, as this one is here, or y equals a number is a horizontal line. Okay, let's put horizontal right here, or horizontal. We'll stop right there. Okay, so the fixed distance is called p. So from the vertex to the focus is p. It's lowercase p. Okay, so lowercase p, distance from vertex to focus. Okay, lowercase p. That's going to be used in our equation. Okay, now that same distance from the vertex to the directrix is also p, the lowercase p there. Okay, there's the same distances. You know that. That's going to help us and know how to graph things as well. Understanding this form can actually make graphing the parabola a lot easier than the ways you learn it in Algebra 1. And we'll see that coming up. Okay, so that's the definition. Now, within parabolas, we have concavity. Concavity is about how the parabola opens. Does it open up, down, left, or right? So as we see right here, concave up because the parabola opens up. Concave down because the parabola opens down. Concave right, it opens to the right. And concave left because it opens to the left. So that's dealing with concavity. Okay, and that's what these two right here say. The vertex of the parabola is a point on the axis of symmetry. So here's the vertex. Therefore, this is the axis of symmetry. Okay, the y-axis, remember that equation is x equals 0. And I'll say AOS for axis of symmetry. So if I say what's the AOS of this parabola, it would be x equals 0. Okay, now remember, if I was to throw in the other things, um, if it opens up, A is positive. Well, in this case, we're going to be talking about P. So P is positive. If it opens down, P is going to be negative. If it opens to the right, P is positive, and if it opens to the left, P is negative. Okay, when we get to the equations here, right below here, coming up. Okay, so let's get to it here. Okay, the standard form parabola with the vertex at the origin. So the first day, because we're splitting this over 2 days, all our vertexes or vertices are at the origin. It's going to have the form of one of these two. That's why you see the word or. It's not both. You don't get to just choose. It's one or the other. You have to figure out which one it is. Now, where does that come from? That comes from the actual equation of a parabola that's in this form right here. And remember, h comma k is the vertex, okay, just like it was in a circle. Okay, and notice you have the minus signs in there, which also means opposite. So if it's in this format with the parentheses, if it's got parentheses, notice these ones don't. And I'll explain why in just a second. But if it has parentheses, that means it's shifted off of the vertex being 0, 0, the origin. It's going to move it left, right, up, or down. Okay, so if no parentheses, as we have over here, then it's at the origin. If there are parentheses, the vertex is being shifted off the origin. Okay, and we're thinking opposite, opposite when it's written like this. Okay, and we'll get into that in the um, second half of the video, or if I make it two different videos, the second video. Okay, so why is it this right here? Well, if I think about this, if I plug in 0 right there and 0 right there, because the vertex is the origin, and that wipes that out, and all I'm left with is x squared equals 4py. When I plug in 0 for h and k. Okay, so that's exactly what that says right there. So these are not really two different equations. They're the same equation, just plug in h and k as 0 and 0. Okay, so if you're only going to memorize one, this is what you want to memorize, because this takes care of any condition, whether it's at the origin, I plug in 0, 0, or if it's off the origin, all right there. Okay, so like I said, the first half of this video is going to be focused on being at the origin when I do examples, and then we'll do them off the origin. Okay. Remember, since the vertex is somewhere, it's got to be inside, the directrix would have to be outside. Vertex is somewhere inside, directrix is outside, like that. Vertex is inside the parabola, directrix outside the parabola. Vertex inside the parabola, directrix outside the parabola. Okay, so I'm just adding those in there so you remember. So if you need to refer back to this, that you make sure you put the vertex in the right spot inside the parabola, the directrix is outside. So when you're graphing your parabolas here, you can see how those directrixes should be drawn as well. Okay, if you have to refer back to this. Okay, so we're gonna focus on these first two here. X squared equals 4py. Or y squared equals 4px. Okay, so let's go back and I'll list them on here. If the parabola opens up or down, which is the concave up or concave down, it's going to be of this first form right here, y equals x squared. So this is the x squared equals 4py, x squared, oops, let's make that x squared nicer, x squared equals 4py. If it opens left or right, it is now the reverse, switch the x and the y. So we have y squared equals 4px and y squared equals 4px. Okay, now what's the difference when I got two of them the same? Remember, this one, p is positive. So that's the difference right there. P is going to be positive. Here, p is going to be negative. So it's going to have a negative number for the p. And that makes sense, right? So you start from the vertex, and I'm going from the vertex to the focus. I'm going down a certain distance, whatever that distance is, 1, 2, 3, whatever, it may be a half. So that's why p is negative. If I start here, I'm going up, and that makes p positive. Okay, if I start at the vertex right here, I go to the right, that makes p positive. That's why p is positive. If I start at the vertex here and I go to the focus, boom, that makes p negative, which is why it says p is negative. Okay, so those are rules, okay, and knowing whether p is positive or negative. You go from the vertex to the focus. Okay, so let's go ahead and I'm going to write equations, and then we're going to graph some couple, and then I'll graph a couple, and then we're going to write the equation form, go backwards. And so again, because there's no parentheses on all of these right here, the vertex is at the origin, which is 0, 0. Okay, so let's say I have x squared equals 8y. Okay, So let's make a graph right here. Oops. Okay. Now, we know the vertex at the origin. Make it red here. And notice the number in front of the y, what's in front of the y is 4p. So I set that equal to 4p. 4p equals 8, p equals 2. Since p is positive, and remember it's in the form of y equals x squared, what I should go ahead is draw my parabola of that shape right there. And I know the focus has to be on the inside. The directrix has to be on the outside. So I know it needs to look like that. So since P goes to my focus, I'm going up 2, 1, 2 right there. And there's my focus is at 0, 2. So if it asks what's the point coordinates of the focus, 0, 2. And since, remember, this is the P, it's the same distance away, I'm going 2 down, except for this now is a dashed line. And that equation is y equals -2. Okay, now how can I get other points? Here's the shortcut way that is not in this book here that I've learned in many other books in years past. In Washington State, for example, okay, which unfortunately they don't do it here, is from the focus going out this direction, 1, 2, 3, 4. This is 2p right here, and I go 1, 2, 3, 4. I shouldn't have made them solid because remember, it's not really there. Should have made them dashed. So make yours dashed. But I have 2 points right there. And so now I can just quickly do my sketch of my parabola right through those right here. So this total distance is 4p. You're going 2p in each direction. Okay, well, obviously we know it. So the total distance better be that 8. There's that 4p right there is 8. So half of 8 is 4. So I'm going 4 and 4 in the, and since it opens up or down in the horizontal distance or directions from the focus. And there you go. That's what all you need to do. That's the quickest way. You see how quick that is to graph that. Okay, let's do one where it goes left or right. For example, right here. And we'll make p negative. So let's go y squared equals negative 12x. Okay, so remember if it's x equals y squared, it opens left or right. And since p is negative here, because I know 4p is 12, negative 12, so p is negative 3, that means it's opening to the left. And why do I know that? Because the focus has to be on the inside. And I know p is negative 3. Okay, because I have 4p equals negative 12, so p is negative 3, so that means I'm going from the vertex left 3. Okay, and remember the focus has to be on the inside, so that means the parabola has to open like that, and the directrix will be out over here. So when I'm down, I better have something like this. Okay, drawn. All right, so let's go ahead and graph that now. Okay, so again, we know it's at the origin because there's no parentheses to shift the vertex. So let's go back and say vertex 0, 0, plot it. Okay, we just calculated p negative 3, so that's always from the vertex 1, 2, 3, left 3. Okay, so negative 3 equals p if you want, just to see that, which means that I'm going the other direction 3, and then I'm drawing a vertical line since it opens to the left. Okay, that's x equals 3 for the directrix, put dir for directrix. Okay, because you're going to be asked what's the equation of the directrix at some point. There you go. Okay, we know it opens to the left. We've already got the general shape right here. And remember, we know 4p is negative 12. So it's 6 and 6. 1. Let's change the color here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's move it down a little bit. 6. Okay, and now I can go ahead and draw my parabola through those right there. Okay, and this total distance of that 4p, remember this is just dashed, that total distance of 4p, that segment itself is called the lattice rectum. Okay. Again, it's not in this book, but that's the fastest and quickest way to go ahead and graph a parabola in this form. It's very quick. And we're just going half and half. So that's a total of 6. That's a total of 6 for a total of 12. Okay, and we have our parabola drawn. So this is why you need to pay attention to the sign when it opens left. So if it's negative, it's opening to the left. If it's in the form of x equals y squared. If it's positive, it's opening to the right. If it's in the form of x equals y squared. If it's positive over here for y equals x squared, it's up. And if it's negative for the 4p, for the p is negative, it'll be opening down. Okay, so there's examples where they give you the equation to begin with, and then we drew the parabolas. Now I'm going to go ahead and draw a parabola. No, I'm going to give you conditions, the focus and the directrix, and you're going to come up with the equation of the parabola. Okay, so given focus and directrix, write equation of parabola. Okay, so let's say the focus is 0, -3. The directrix is going to be y equals 3. Okay, what's the equation? Okay, now you can either visualize this, or if you have trouble with that, just go ahead and plot it. So xy axis here. Okay, focus is 0, -3, 1, 2, 3. That's the focus. The direction is 1, 2, 3. Y equals 3 right there. I know the vertex is the midpoint between those. The midpoint is the origin. Therefore, okay, so he's at 0, 0. Okay, we know that the parabola, the focus is always inside. So we know, therefore, it has to open down. Okay, because the focus is inside. It cannot ever cross or touch the directrix. Think of that. It can never cross or touch the directrix. It's got to go in the opposite direction of where the directrix is. Okay, that's another way to think about it. Okay, now what is P? Isn't P the distance from the vertex to the focus? Didn't we go down 3? So P is -3. Okay. Now, since it opens up or down, we know it's y squared equals 4px. And now all we have to do is plug in that p, which we just calculated to be -3. So y squared, 4 times -3 times x. So y squared equals -12x. There's our equation right there. Okay, let's do another one since I'm trying to do, so we hit all of them. Remember, we didn't have a negative parabola open down on the first one we graphed it, so I made this one open down. That last one, left to right, open left, so we'll make one open to the right. Okay, so let's say the focus is -4, 0. The directrix would be x equaled 4. Okay, so again, you can plot it, x and y axis. Okay, -4, 0, 1, 2, 3, 4, -4, 0. That's our focus. The directrix is 1, 2, 3, 4. There's our directrix. We know it can't cross the directrix. It's on the ends. The focus is on the inside. The midpoint is 0, 0. So we know it has to open something like this. We're not actually graphing it accurately right now. We're just getting the shape so I know what general equation to use. So since it's open left to right, it's y squared equals 4px. Okay, left to right, it's x equals y squared. And remember, the p is always from the vertex to the focus, which is 1, 2, 3, 4. -4 I went. Make sure you put the sign with it. And you're always starting at the vertex. So p is -4. So now all I have to do is take that -4 and plug it right into that equation, and I'm done. Okay, so this answer therefore be y squared equaled 4 times -4 is -16x. That's the equation of that parabola with a focus of -4, 0, and a directrix of 4. Okay, so we've done on the last page, we started with the equations, we graphed them. This page, we started with a focus and some given information, focus and directrix, and we wrote the equation. Okay, y squared equals -12x. I'm just bringing it up here. Okay. Um, Remember, you need to pay attention to P. P goes from the vertex to the focus every time. Not from focus to vertex, but from vertex to focus. That's the key, so you get the right sign of P, positive or negative. Okay, so now let's go ahead and add in shifts. So the vertex is not at the origin. So let's have y minus 2 squared equals 16x plus 1. Okay. So again, I'm looking at it. It says x equals y squared. X equals y squared is left or right, isn't it? So I know it's left or right. Here is my 4p right there. So I solve for it. I get p equals 4. So that means from the vertex to the focus, I'm going right 4 to positive 4. So that means it has to open to the right. Now my vertex, identify my vertex first. Remember, opposite, opposite. So I look for the x coordinate. So it's positive 1. So the opposite is -1. I go to the y coordinate. Opposite -2 is positive 2. Okay. So plot that. -1, 2. We'll just do 1 per page here. -1, 2 right there. Vertex. Okay. And remember, go ahead. X equals y squared. Since p is positive, I'm opening to the right. X equals y squared. So I know it's going to look like this. So again, that's going to tell me you should do that from the equation itself. Always draw that general shape first, know what it looks like. So now I got the vertex, and since p is positive 4, I'm going to go right 4. 1, 2, 3, 4. There's my focus. And then remember, p, 4p is 16, so 8 and 8. Go up 8 and down 8. Oh, I can go left 4. 1, 2, 3, 4. And graph in my directrix. So directrix, oops, x equals, remember I need vertical line is x equals, and it's -1, 2, 3, 4, 5. X equals -5. Remember, you got to keep count of where that is because it's not at the origin anymore. Notice this is at 3, comma 2. So it's going to ask you, what's the focus? The answer is 3, comma 2. What's the directrix? The answer is x equals -5. Okay. Now, we know that it's 4p is 16, so I'm going up 8 and down 8. 1, 2, 3, 4, 5, 6, 7. Can I go up one more? 8. 1, 2, 3, 4, 5, 6, 7, oops, 7, 8. So boom, way out here like this. And all the way, I can't keep going, but like that. There you go. There's your parabola right there, graphing it. Notice the vertex is not at the origin this time. We did opposite and opposite. Okay, so that was a left or right one. Let's do one more for up or down. Okay, so we did a positive one there. Let's go make a negative one for the next one here. Okay, so we want y equals x squared now. Say x minus 2 squared equals 4p. We'll make it -8, and y plus 4. Okay, so again, y equals x squared is either up or down. And since the 4p right there is -8, p equals -2. So that tells me it's down because p's got to go down. It focuses inside. So it's going to be a parabola opens down. Remember, we're doing opposite, opposite. So the vertex, I look at the x-coordinate right here. So opposite of -2 is 2. Go to the y-coordinate, opposite of 4 is -4. Okay, so now go ahead and plot that. I know it's going to, in the focus is going to be somewhere down in there. Okay, so now go ahead and plot that, 2, -4. 1, 2, 1, 2, 3, 4. 2, -4 is the vertex. Put a V for that. Okay, P is -2, so I'm going down 2 more. There's my focus. I'm going up 2, drawing the horizontal line. What's the equation of that line? Y equals -2. We know the vertex is 2, -4. The directrix, that's the vertex. The focus is, we went down 2 more, so -2, -6. You got to be able to plot and identify your points correctly because they're going to ask you that. Okay, now we can get our other 2 points easily. 4P is a total of 8, so I go out right 4 from the focus. 1, 2, 3, 4. There's a point. 1, 2, 3, 4. There's another point. And now I just go ahead and draw my parabola. Make sure it keeps going out to the side. Okay, it's going to get wider and wider like that. Okay, I saw some of you that tried coming down and have it come almost straight down like that. It does not do that on any parabola. Okay, unless it's a really narrow one, then it's going to go more like that. All right, so there's an example again of another parabola that is off, the vertex is off of the origin there. Okay, again, opposite and opposite to get those. Okay, so if I was filling this in over here, focus, -2, -6. So in directrix, y equals -2. Okay, if it asks for intercepts, does it cross the x-axis anywhere? No, it doesn't. So in this case, there'd be none. Okay, if we went back here and they wanted the intercept, we'd be having to find that point right there. Okay, well, what coordinate do we know is 0 on the x-axis? The y-coordinate. So if I actually want to find, if it asks to find the intercepts, there's only one, right? Only cross the x-axis one time right there. Intercept, if it opens left or right, or it doesn't matter, you're setting y equal to 0 and solve the equation. Okay, so we'll go ahead and do that. So I plug in 0 in for the y, I get -2 squared is +4. And then I have 16 x plus 1. So I'm going to divide by 16 on both sides. So I got 1/4 equals x plus 1. Last step, subtract the 1 across. And I get 1/4 minus 1 is -3/4. So the x coordinate, this right here, where that hit, that'd be -3/4, comma 0. Okay, so there's an example of how, if they ever want you to find the intercepts and it's not at the origin itself, you set the y value in your equation, doesn't matter which equation is, opens up, down, left, or right. Well, when we're talking about the intercepts, I didn't look in this book if they want, if it opens up or down, if they want the y-intercepts or they want the x-intercepts. So I'm assuming right now when I'm teaching this that we're talking about the x-intercepts where across the x-axis. So that's why we're setting y equals 0. But let's say you found out they wanted the y-intercepts where across the y-axis. Well, then that would be 2 points, right? Across the y-axis right there and across the y-axis right there. 2 points. Well, if we're going to find the y-intercepts, so there'd be 2 y-intercepts, okay, to find y-intercepts, it's going to be the exact opposite of that. Set x equal to 0 and solve. Because any point on the y-axis, the x-coordinate is 0. Okay, so that's just sort of some common sense there. Okay, so if they said y-intercepts, you're going to set x equal to 0. If they say the x-intercepts, you're setting y equal to 0. Okay, so we'll go ahead and find the y-intercepts, or the y-intercepts, so we're going to set x equal to 0 here. Okay, so like to finish up here, let's go ahead and find the y-intercept. So we're going to set x equals 0 and solve for the y now. So we go back up to the equation. We set x equal to 0. And 0 plus 1 is 1 times 16 is 16. So we have 16 on the right equals y minus 2 quantity squared. Y minus 2 quantity squared. And you saw that for y. It's a squared. Remember, that tells me there's two answers, which makes sense because don't we have two answers right here? We have this answer and we have this answer up there. So that makes sense. So we got to take the square root of each. So I have y minus 2 equals plus or minus. When I take the square root, that means plus or minus the square root of 16 is 4. Last step, add the 2 across. So I have 2 plus or minus 4. Remember, these are just the y coordinates. So I have 2 plus 4, which equals 6, and 2 minus 4, which equals negative 2. Okay, so this should be at negative 2. Okay, so I must have got shifted. It was there. There's my negative 2, and this should be up at 6. 1, 2, 3, 4, 5, 6. Just right there. Okay, for the y coordinates. Remember, x was 0. So we have x is 0, and one is 0, 6, and the other one, x is 0 and negative 2. That'd be my y-intercepts. Okay, so I want to show you both ways in case they asked for the actual y-intercepts. Usually when they talk about the intercepts, it's usually x-intercepts, but just in case they were to ask you for the y-intercepts, now you know how to solve for those. Set x equal to 0. Okay, so now you've covered everything that you need to know about parabolas in this form, both with the vertex at 0 and the vertex not at the origin.